going to work on graphing systems of inequalities. But before we do that, we actually need to figure out if a certain point is a solution to the system of inequalities to begin with. Raise your hand and tell me, what would I need to do with that 3 comma negative 1 in order to figure out this answer? Plug it into how many equations, Kathy? With both equations. So I'm going to go ahead and do that. If I plug it into this first equation, 3 plus negative 1 is less than or equal to 6. I get 2 is less than or equal to 6. Is that true or false? True. Okay, since it's true, I then check the second one. If that was false, do I even need to check the second one? No. I could save myself work. But I have to check the second one. Minus negative 1 is greater than 4. 6 plus 1 is 7. Is 7 greater than 4? Yeah. So we write the word yes. I don't write 2 yeses. I write 1 yes to prove that it's a system. To prove that it is a solution to the system. Go ahead and try the other point, 2 comma 0 at this time. Plus 0 is less than or equal to 6. Yes. 2 times 2 minus 0 is greater than 4. Is 4 greater than 4? No. I do not write the word yes and then the word no. I just write one word, no. Some of you, whenever we were checking if the point I was giving you was a solution to the system of equations, you would write both a yes and a no. So on these, make sure you're only writing one word. Any questions? Well, since we're working on graphing this, let's go and graph. So we already wrote down the equation. What do I need to do with that first equation in order to graph it? Good. So x plus y is less than or equal to 6. We subtract x. Y is less than or equal to x, negative x, plus 6. Now, I know when you see an inequality, you're thinking you have to shade, right? And you will have to shade. We're actually going to change your method of shading here slightly. That way, when you're working on the project tomorrow, it makes it look a lot nicer. So go ahead and graph that line. Would it be solid or not? Solid. Go ahead and graph that solid line, but do not shade yet. Once you draw your line, just stop there and look up here for a minute. Because this new piece is brand new. If you had Mr. Ryan, I believe he actually gave you 2 colored pencils, had you shade both of them, where they overlap, that was the solution, right? Which works great on this easy type of problem. But when you go to make your own picture on tomorrow's project, if you take a look back here on the wall, there's a lion, there's a heart with an arrow through it, Ohio State and love. There would be colors all over the place if we tried to just shade with several colored pencils. And so instead, I do a little arrow method. Am I going to be shading up or down from this line? Down because of less than, right? So I find the y-axis and I put an arrow going straight down. And I actually do that to a couple points on that line. So I know, technically, I'd be shading all along here, right? but I'm only looking for where these two lines overlap. Now that we have that part done, go ahead and solve the other equation for y and graph that line. You remember to switch your sign? Okay, and now solid or dotted line? Ah, you remember to do that. Giving people just a few minutes to make sure that line is right. Would I be shading up or down from the dotted line? Down, right? Because it says less than. So I'm going to start at the y-axis. I'm going to put an arrow going straight down. Everybody see that? Where do the two sets of arrows overlap? Do they overlap up here? Do they overlap here? Do they overlap here? How about down here? Yeah. So I just shade right in there. Notice I don't have two different shadings going on that graph. I only have one shading. That's why the arrow method is so important. Especially when you start to do 5 or 6 lines all at the same time. You're thinking, oh no. When you make your own picture, maybe you want 5 or 6 lines to make an awesome picture. You want to only have one shading between them. Alright, let's have you try another one. This is an easy hoy buck problem. Go ahead and you try it. So for those of you that are done, I drew my first line on. I like to put the arrows on. I draw a line, I put an arrow on it. I draw a line, I put another arrow on it. So here's my first line, and it does say X is greater, right? Is greater on this side or this one? Okay, it's on this side. Now this is the only time you get to draw a left arrow or a right arrow. Otherwise you draw an up arrow or a down arrow. This is the only exception to the rule. Now, I'll graph the y is less than or equal to -3, solid line. And less than is down, right? Do you see where they overlap? Right here. Any questions? Raise your hand if you got that one. Good. I have a question for you. Is the point 4 comma negative 3 a solution to the system of inequalities? Discuss with your group. Is the point 4 comma negative 3 a solution to the system of inequalities? Leaders, make sure you are answering that question. Is it a solution to that system of inequalities? All right. You have 2 options here. Raise your hand if you look back at the equations and you went with those. Okay, so maybe you did? Okay. In my other class, 50% of the students look back at the equations. That's what I would do too. Okay? And I noticed right away 4 is not greater than 4. So no, it's not a solution. Why is my graph telling me no, it's not a solution also? The dotted line. Dotted lines do not count. Meaning if it's on a dotted line, it is not a good point. So no, it is not a solution. Okay. Go ahead and try this one. Remember, draw the first line, solid or dotted, put arrows. Then do the second line, solid or dotted, do your arrows. Make sure the arrows on. Draw these. I'm going to go down 3 over 1, down 3 over 1, up 3 over 1, up 3 over 1. Solid or dotted? Now the next thing we do is we put arrows on. I don't even go to the next line. I put arrows on right away. It says greater, so up. You need to put the arrows going straight up. Do not put them going so they're going sideways, because that's going to throw you off on harder problems. Right now this is a nice easy problem. I don't want you to be confused later. Now I'll draw the other one. Positive 2, up 1 over 1. Dotted line. And on this one, the arrows would be going down. So notice I found a point, I just put an arrow going straight down. Oh, they seem to be overlapping. Right in here. Now, raise your hand if you're one of those people who like to do those perfect shading. Okay. If you are, that's okay. You can take your time to shade. When we get to the pictures, I want pretty shading, so that'll be good. Tomorrow you'll get a project where you're actually working your pictures. But I'm actually going to give you the rest of the class at this time to work on the essential work. 6 and 7, you want to do them beside the same graph. They're yes and no questions. The rest of them then, there's 5 graphing problems. So you need a clean sheet of graph paper, which you should already have. Here's the rest of the period.